This is a separate video from the main notes on transformations that you should watch if you're confused about transformations. In this one, I'm just going to go through filling in the notes so that we're clear about kind of this summary of all the things we talked about in the other video. So function notation rules are all of these things where we have something happening to f of x. Our vertical rules always happen outside the parentheses. And if we have k here, these are our vertical shifts, which we call translations. So these are shifting up k units if k is positive, or down k units if k is negative. So we have shift here, that's kind of our informal word, and the formal word for these two is translate, like when we move something. The second one is a reflection. So we can say that here, but I'm going to stick with the informal words over here and put flip over. So if we're reflecting vertically, think about a graph, we're reflecting from here vertically to here. The thing we reflect over is the x-axis. So this is a flip, and then our formal word for that is a reflection. These two are our stretches, or I don't know, dilations. They're like the half dilations where we're taking something and we're stretching it either just in the x direction or just in the y direction, but not both at the same time. So I'm just going to use the actual words over here. So a f of x, if we multiply by a number bigger than 1, we vertically stretch. And if we multiply by a number between 0 and 1, meaning a fraction or decimal smaller than 1, we vertically compress by a factor of a, by a factor of a. So those are all the vertical rules, and that's what goes in there. Horizontal rules happen inside the parentheses. So all of these changes, f of something, it's changing the x part, not the whole thing, not the f of x part. So these are, again, our translations. So H is our letter for translating. I like that one because it stands for horizontal. It has more meaning to me than the K one we did above. So all of the horizontal things are weird and backwards. So these are the backwards things we talked about in the main notes. So f of x plus h shifts left by h units. We would think that it would go right because plus is right, but it's all very backwards. So x minus h is a shift right by h units. This is our reflection, so reflect, and so this time we're reflecting horizontally, so from here over to here, the axis we're crossing is the y-axis. So this is a flip over the y-axis, or you can put reflection, whatever. The multiplier, so a was simple, it was just a times f of x, but b, the multiplier for horizontal stretches and compressions, is weird and backwards, just like h is. So if we have b greater than 1, we're doing a horizontal stretch, just like when we had a greater than 1, but when it goes into the equation, it's not bx, it's the reciprocal of b times x. If b is between 0 and 1, that's a horizontal compression, or compress. And again, it goes in as its reciprocal. So if I have, just think if I have b equals 4, then when I plug it in a function rule, it looks like f of 1/4 x. So weird and backwards just in the same way. These were backwards in that their sign reversed. We changed plus to minus, so we call that an additive inverse. This one we are making the reciprocal, which we call the multiplicative inverse. So these are all just reversed from what our intuition says they should be. It's super weird and backwards. Okay, so these are some examples of all of those. So I'll just go through writing those and the way, we'll just go through and apply each of these rules. So this is k is being added outside parentheses. So shifting up by 2, we said would be k equals 2. Our function notation is f of x, so that's just what it was, that's the y values, and then we add 2 to all of them to move them up by 2. So this is the function notation or rule that transforms a function. We're starting in all of these cases with this function right here. And so far, shift up 2 and this f of x plus 2, I didn't care what the original function was. I could transform anything according to this rule. But now to apply it, to get the final changed transformed function, I'm going to now care about this original one over here. So f of x equals 2x plus 3. So where f of x goes, I put 2x plus 3, and then after the f of x is a plus 2. Then we're going to combine like terms, and I'm going to put g of x, our transformed function, equals 2x plus 5. So that's how we apply. We found k. We wrote a function notation, which we call a rule for how we're transforming, and then we wrote the applied function in the new, the new function notation. Shifting down by 5, k is going to be negative 5. Our function notation is going to be f of x minus 5. And then to apply it, we would do 2x plus 3 minus 5. So our transformed function g of x is 2x minus 2. Reflecting over the x-axis, that's where we put a negative f of x. So negative f of x like this reflects any function in the world over the x-axis. To apply it to this one, we put negative, and then f of x is 2x plus 3. So that negative applies to the whole thing, and we need to distribute it. And we end up with g of x equals negative 2x minus 3 as our transformed function. Vertically stretching by 3, we put a is 3. Our rule would be 3 f of x. So that gives us 3, and then f of x is 2x plus 3. So our transformed function, g of x, would be 6x plus 9. Vertically compressed by 1/4, a is 1 over 4. Our function notation is f of 1/4 x. So we get, whoa, I wrote that backwards, sorry. I got ahead of myself and started thinking about horizontal things because they're coming up. A goes outside, 1/4 f of x. So we're going to do 1 over 4, and then we're going to have 2x plus 3. We distribute that. 2 times 1/4 is 1/2 x, plus 3 times 1/4 is 3/4. And that was equal, g of x equals. I forgot to put it, so I'll put it on the right. Okay, that's all of the types of vertical transformations we can have. And then finally, horizontal transformations. This time we're starting with this f of x equals 3x minus 1. And remember, this one's going to be all weird and backwards. So shifting left 4, h is negative 4. But now, when we go to put it into a function notation, it's weird and opposite. So we're going to put f of x plus 4. So our shift is to the left, but then we're writing it as x plus 4. And then to apply it, f of x plus 4, what we're doing is swapping out the x, and everywhere x was, we put x plus 4. So we're going to put g of x equals, and then we put 3 like we had here, and then in the original function we come to where x was. Where we see x, we're going to replace that by x plus 4, and then we continue on with the original function and put minus 1. So now we would distribute. I don't have room to write it, so I'll just say it would be g of x equals 3x plus 12 minus 1. So we end up with 3x plus 11 as our final function. Shifting right by 2, that would mean a horizontal shift of +2. But once we go to write it in function notation, it's weird and backwards. So we put f of x minus 2. And to apply it, we do 3 times, and then where x was, we put x minus 2. And then we have our minus 1 from the original function. So just again to be really clear, we're just replacing this x here with whatever happened to x. The rest of it all stays the same. So this 3 and this minus 1 don't change at all. So we still have our times 3 and our minus 1. They don't change when we change a horizontal thing. Okay, so reflect over y-axis. So that is f of negative x. So instead of making everything negative, we're just switching the x part. So the 3 stays the same, then x gets replaced by negative x, and then we have the minus 1 like always. So combining these two, we'd get negative 3x minus 1 as our finished function. Horizontally stretched by 2, so b is 2. But then, in function notation, just like the other horizontal changes, it's weird and backwards. So here it's going to be the reciprocal of 2. So 1 over 2 times x. So to apply that, we do 3, and then where x was, we replace it by 1/2 x, and then we put the minus 1. So just like all of these, this 3 isn't changing, and this minus 1 isn't changing. It stays the same. All that's changing is the x part, and then the x part gets multiplied by the slope, so we would have 3/2 x minus 1. And then finally, a horizontal compression, b is 1/2. But when we go to write our function rule, it's going to be f of the reciprocal of b, so f of 2x. That means we have 3 times 2x minus 1, which is 6x minus 1. So that fills in the notes, and the key thing to remember here is these weird backwards things that happen on horizontal.